Welcome students. Today our lecture is lecture number 4 and we have to discuss some topics of types of matrices. We have discussed some topics in previous lecture and in this lecture I will discuss further. So the first type of today is diagonal matrix. So what is a diagonal matrix? According to definition, a square matrix in which all elements are zero except the diagonal elements is known as diagonal matrix. So first thing, the matrix must be diagonal and all entries are zero except diagonal entries. So what are diagonal entries? These are diagonal entries. First element of first row, second element of second, third element of third, fourth element of fourth, up to so on are the diagonals. So if all the entries are zero except the diagonal entries and also the diagonal elements are not same, so that matrix is a diagonal matrix. The matrix must be square matrix and all elements are zero except diagonal elements. The next topic is scalar matrix. This matrix is also a square matrix, and in this matrix all elements are zero except the diagonal elements, and also diagonal element must be same. In diagonal matrix, diagonal elements are different, but in scalar the diagonal entries are same. If you look at the first example, matrix A, off diagonal is 0 and diagonal elements are -1, -1, -1. It's same, so it is a scalar matrix. If you look at this second matrix, diagonal entries are same and off diagonals are 0, so this matrix is also a scalar matrix. The next topic is identity matrix. What is identity matrix? It's also a square matrix. If you look at the definition, a square matrix in which all elements are zero except the diagonal, and diagonal element must be 1. In identity, diagonal element must be 1 and off diagonals is 0. In diagonal matrix, the diagonal entries are different and off diagonals are 0. In scalar, diagonals are same and off diagonals are 0. But in identity matrix, these diagonal entries are same, but it must be 1. If the diagonal entries are not 1, maybe -1 or any other number, positive or negative, then it's scalar. And if it's +1, then it is identity matrix. Now, next topic, transpose of a matrix. What is transpose? According to definition, if we change rows into columns and columns into rows, the obtained matrix is the transpose of that matrix. If you see in the example, this is a matrix A and the entries are 3, 2, 1, 0. This 3, 2 is row and first matrix, but if you see in this next matrix, this is interchanged into column and the second row is interchanged into second column. So the transpose of any matrix can be obtained by interchanging its row and columns. Now, what is symmetric matrix? A square matrix is symmetric. First of all, symmetric matrix must be a square matrix. That is, number of rows and number of columns must be equal. So a square matrix is symmetric if and only if transpose of any matrix is equal to original matrix. For example, if you look at the example, this example A, if you see matrix is square matrix, first condition lie here, and if you see that if we obtain the transpose, we change first row into first column, second row into second column, and third row into third column. And if you look at these two matrices, the two matrices are same. That is, here A is equal to A transpose, so A is a symmetric matrix. Now what is skew symmetric matrix? A transpose is skew symmetric if and only if transpose of any matrix is equal to negative of original transpose. That is, the sign must be changed of all elements. If first element is positive, then in transpose it must be negative entry. Number is same but in negative sign. For example, if you look at this matrix, here if you see the first row is 0 minus 3, and in transpose the first row is 0 3. That is, we have to change first row into first column and second row into second column. Now if you look at these two, 0 0, negative 3, positive 3, the sign is changed, 3 negative 3, 0 0. So the sign has been changed. In this second element is 3, here is also 3, but the signs are changed, positive 3, negative 3. So A is skew symmetric because transpose of A is equal to the negative of original matrix. So in skew symmetric, the transpose is always equal to negative of original matrix. Okay, hope you learn this. In next lecture I will discuss exercise 1.2 of 9th class mathematics Abbottabad board. Hope you enjoy these videos. If you enjoy, like it and share it.